So I've got Mr. Smith sitting next to me, keeping an eye on me here. My job is to try and show you an easy way of producing ionic half equations. Now, this is one of the most challenging parts of the higher tier chemistry that we're asking you to do, but it's really nothing to be scared of, although it looks awful. Okay, you're going to be confronted with a question that says something like, what is the half equation for the half equation, forgetting how to write, for the neutralization of an acid using an alkali, There we go. Alkali. Okay. Well, that sounds awful. But you know what neutralization is? Neutralization means something like an acid plus a base produces a metal salt and something else. And that something else is water. Now remember though, if you're using a metal carbonate as your base, it will produce carbon dioxide as well, but that's going to be the next video that Mr. Smith asked me to do. Okay, we need to know what acid we're going to use, and we need to know what alkali we're going to use. Well, an alkali is a base that dissolves in water. And I'm just going to pause for a moment and look over my shoulder at Mr. Smith and say, how are we doing? Okay, so it's a base that dissolves in water. All right, and that in turn means it's a metal, hydroxide. Oh dear, I've run out of space. But now I've got to point one nasty little thing in. It's actually not any metal hydroxide. Think about solubility rules. It will be potassium, sodium, or lithium hydroxides. Because from your solubility rules, you know that most metal hydroxides are insoluble. That's the stuff that looks like bogies when you do a precipitation reaction. Okay, now getting confused with my diagram here. So which acids could we use? Well, there are only three really that you guys need to worry about for the moment: hydrochloric, sulfuric, and nitric. Okay, well, we're getting there. So now we could say, for example, hydrochloric acid plus potassium hydroxide leads to the metal salt. Well, the metal is potassium, and the salt comes from the acid, and we know that hydrochloric acid produces a metal chloride. And the other bit is water. Now, here's the problem. This is only your grade 3, maybe a grade 4. This is certainly grade 4. To get to the grade 5, we need to start doing the symbol equations. Okay, so we're going to tackle this horrible symbol equation. All right, well, hydrochloric acid is HCl. And while we're at it, sulfuric acid, H2SO4, and nitric acid, HNO3. Those three you need to remember for us, okay? So we're going to take the HCl and we're going to put it in over here, HCl. Now, potassium hydroxide. Well, potassium has the symbol K. Potassium comes from group 1, which means it's got one electron in its outer shell, which means it needs to lose one for a stable structure, which in turn means it's going to form a K1 plus ion. But remember, in chemistry, when there's only one involved, we don't use the one, we don't write the one, I should say. So it's just K plus. Now, hydroxide is the OH minus ion. Plus one from there. Oh, plus one. This tells us there's a minus one. Now, this is kind of a tricky bit, but what it means is the formula for potassium hydroxide is one potassium ion bonding with one hydroxide ion. And Mr. Smith's just been adjusting everything because I've moved the paper and caused trouble. Okay, so now we're over here, we've got KOH. That's leading to potassium chloride. Well, you've already found out that potassium forms the K plus ion. Chlorine, I'm running out of space here, Cl, group 7 electrons in the outer shell, so it wants to gain one. And this is the bit that confuses students from time to time. It's gaining something with a negative charge. If it's gaining something with a negative charge, it means it's going to form a Cl minus ion. So the formula for potassium chloride is K balanced by the one negative chloride ion. So we've got KCl there, and the formula for water, you're all screaming at the screen already, is H2O. Okay, this is an aqueous solution. It's dissolved in water. This is an aqueous solution. It's dissolved in water. Aqueous solution. But remember, water is a simple covalent bond. It's a simple molecule, a tiny little molecule. It's a liquid. Okay, well now we're at grade 5, provided we've got a balanced equation. Have we got a balanced equation? Well, of course we haven't, because it wouldn't be fun if we had. So we're going to imagine some boxes. Now remember, I'm only giving you 4 types of box. I've given you a box with HCl, I've given you a box with KOH, I've given you a box with KCl, and a box with H2O. You're not allowed to change the boxes. You can only have those 2 boxes on that side and those 2 boxes on that side. Bear in mind that sometimes I make it hard and sometimes I make it easy. How many hydrogens are there in this box? Well, we've got 1 there, we've got 1 in that box, so that gives us 2 hydrogens in total. How many chlorines are there? Well, we've got 1 in that box, none in that box, so we've got 1 in total. How many potassiums? 0 in that box, 1 in that box, so that's 1 in total. And the hydrogens we've already dealt with. So have I dealt with everything? 1, 2, 3, 4. I'm missing something. What am I missing? Oh, an oxygen. Yes. So none in there, 1 in there. So that's 1 in total. 2, 3, 4, 5 atoms in total. 1, 2, 3, 4, 5. Excellent. Okay, now we look on the other side. How many potassiums are there in that box? Well, we've got 1, none in that. We've got 1 in total. That's the happy face. How many chlorines have we got in that box? Well, there's 1 there, none in there, 1 in total. That's another happy face. How many hydrogens have we got? Well, we've got 2 in total on this side. Oh, so we've got none in that box, but we've got 2 in that box too. So that's another happy face. And then we've just got the oxygens to deal with. 1 on that side, 1 in that box, but none in that box. Yeah, okay. So it turned out that that one was balanced anyway. The way we'd need to write it is this. HCl, aqueous, plus KOH, aqueous, leads to KCl, aqueous, plus H2O, liquid. That is your bang on grade 5 work. If you can get to that point, that bangs you on for the grade 5. But remember, we started this by saying ionic half equations is a little bit higher level than just a grade 5. So to move on to the higher level stuff, what ions are involved? Well, standard equations test. What ion is present in all acids? H+. But remember, this one is the Cl-. Okay? We talked over here about how we worked out the formula for potassium hydroxide. So it's K+ and an OH-. That's leading to potassium chloride. So that's a potassium ion and a chloride ion. And remember, water is simple covalently bonded, so there are no ions, there are no charged particles. Plus, 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 okay? And we still need the state symbols, but there's going to come a point where I get bored of writing those. Okay. Aqueous, aqueous, and we've already got the liquid in. All right, we've worked out what ions are involved. There you go. We've just about got enough room left on the paper. So next step, eliminate spectators. A spectator ion is an ion that isn't directly involved in producing something new. Okay, so look at your equation. Which ions are exactly the same on both sides? Well, H+ doesn't appear on this side. Something different has happened. In fact, the H+ has gone into the water. Yes? The Cl-. Well, the Cl- is there and it's there. That's what we call a spectator ion, so it can go. We can just ignore it and get rid of it. The potassium ion, well, it's the same there as the same there. Okay, well, that's leaving us with this. H+ plus OH-, aqueous, aqueous, leads to H2O liquid. And for those of you who've been tortured by my standard equations tests over the years, that's the answer to question number 16 or something. H+ plus OH- leads to H2O. Here's the thing. If you can remember that bit, and you're really lucky, and the exam question comes up and says, what is the half equation for the neutralization of an acid using an alkali? The answer is going to be H+, aqueous, plus OH- aqueous, leads to H2O liquid. What we'd prefer you to be able to do is to work through that process to be able to build up your answer, to understand what's going on behind it. But never forget, all you ever have to do is come and ask one of us for help. Thank you very much for listening, and I sincerely hope you're still all awake.